Hello, Stats 300, and this is Professor Gonzalez, and we're going to take a look at homework from the assignment side of ALEKS 6.1. So, what we're doing here is we're taking a look at some of the probability as it pertains to a random variable x with a discrete distribution. Let's get right into it, and I also want you to be aware that I've got a formula sheet down at the bottom right here that takes care of some of these formulas for us that we're going to be taking a look at. This is in chapter 6. So the formulas we're looking at in this particular section is right there, which is the mean of a discrete random variable. We're going to need to get the variance. Now this is the preferred method if we're doing it by hand, which we are. It's just a little easier. Both formulas will work. Notice it says this one is better if you do it by hand. This is a better formula if you're doing it by hand. And then when you want to get the standard deviation, of course, you square root both sides, and that's showing that right there. Okay, so the variance, square root the variance, and the variance becomes the standard deviation when you square root. So that's kind of what's going on. Let's take a look. Let's get back to the very first page and get it going here. It says a family of two children. If the genders of these children are listed in the order they are born, there are 4 possible outcomes. They've got a boy, 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 girl, girl, boy, and a girl, girl. Assume that these outcomes are equally likely. Let X represent the number of children that are girls. So that's really important to kind of hone in on that statement they say, what they're letting X equal, the number of children that are girls, because that kind of tells what our variable is that we're kind of trying to look out for in some ways. And I think what I want to do here is let me take a second to make a tree diagram to kind of talk about, how they got this. So essentially, a baby can be a boy or a girl. You probably already know that. So you got a boy or a girl. And then, so that's the first child. And then the second child, baby can be a boy or a girl. Okay, and so, if you follow this path right here, we're talking that this is a situation where you have a boy the first and a boy the second. Then the next one is this path right here, which brings us to a boy first and then a girl second. Wow, I'm having a hard time using this little pencil today. Maybe if I zoom in, it'll get better. So you have a boy and then a girl. And then this third option, we've got a girl and then a boy. And then finally, we have girl, girl. So that's kind of a visual way to show how they end up getting the list of these boys and girls. Now remember what I highlighted here. It says let X represent the children that are girls. So really that's what we're kind of honing in on. So that means, let me use another color here. That means we're looking for when we have girls. So how many girls do we have in this first option? 0. How many girls do we have in the second option? Boy, girl, 1. How about this one? Girl, boy, 1. And finally, girl, girl, 2. So that's what we're counting. It tells us right there that we're counting the number of children that are girls. And so that's why I highlighted that. It really kind of drives what we're looking for. So part A says, find the number of possible values for the random variable X. It's very common to look at this and think there are 4 values, but since we're looking at when the first and the second child, we're looking for the number of girls, well, there's only 3 different possibilities, right? There's 0 girls, there's 1 girl, and then there's 2 girls. There's only 2 children. They can't be 3 girls, right? So there's only 3 possibilities there. Now we want to fill out the probability distribution table. And let's see, we want to go to how many decimal places? 4 decimal places. And how do you do that? Well, this, of course, is telling us 0 girls. Well, what's the probability of getting 0 girls? Well, when I look over here, I see that there is one situation where we have 0 girls out of how many possibilities? 4. And so if I were to turn that into a decimal, of course, that would be, and let me just kind of separate this a little bit. So then that would be 0.25. So what's the probability that we have one girl? Well, over here I see 2 ways of just getting one girl. So that's going to be 2 out of 4, which of course is a half or 0.5. And then what's the probability of getting, so notice this tells us the random variable x, and they're saying the event is that we get 2 girls, and then down here it tells us what's the probability of that, p of x. So this box basically is p of 2. So the probability of getting 2 girls, and you can see over here, there is only one way to get to 2 girls, so that is 1 out of 4, and so of course that is a 0.25. You can see this fits the model of a probability distribution in quite a few ways, and one way to tell is that each one of these probabilities is between 0 and 1, and then we add up 0.25 plus 0.50 plus 0.25, we end up getting 1. Okay. All right, let's move on to the next question. And the next question says, following is the probability distribution of a random variable that represents the number of extracurricular activities a college freshman participates in. So what is this saying here? I think I want to kind of separate this so we can kind of hone in a little better in terms of spacing. So what this is saying is, so once again, I think I would like to highlight what the random variable x is. So it says distribution of a random variable x that represents the number of extracurricular activities a college freshman participates in. So this first one is just saying, it's saying 0 extracurricular activities for the freshman, right? Isn't it freshman? Yeah, freshman participates in. And what's the probability of that? 0.06 or 6%. How about the freshmen that are involved in 1 extracurricular activity? The probability is 0.13 or 13%. 2, 45% or 0.45. 3 extracurricular activities, it starts dropping down to 0.22. And 4 extracurricular activities as a college freshman, 0.14. So you can kind of see this distribution and how it works. Let me just get rid of those for now. And let's see here. Oh, wow, I'm surprised that didn't erase my other stuff. That's good. Got lucky. So now let's see. What are the questions? Find the probability that a student participates in exactly 4 activities. So the notation goes like this. I'm looking for the probability of exactly 4 activities. And that is actually, right, here's 4 activities, and then there's p of x. So this is actually p of 4. So the answer is, what's the probability that the student participates in exactly 4 activities? It's going to be 14% or 0.14. Let's take a look at the next one. It says, find the probability that student participates in less than 3 activities. So with this one, let's see if I could zoom in or zoom out a little bit. What I'd like to show here is a number line. And notice we have how many activities? We've got 0 to 4. So let me show that. 0, 1, 2, 3, 4. Excuse me. And then what I'd like to do, find the probability that a student participates in less than 3. What's less than 3? Well, that's just going to be 2, 1, and 0. So this means what we're looking for is the probability of exactly 0 plus the probability of exactly 1 plus the probability of exactly 2. And that is noted up here, right? The probability of 0 is 0.06 plus the probability of exactly 1 is 0.13, and the probability of exactly 2 is 0.45. Now we add all that together. What is that? 0.06, 0.13, and 0.45, and we get a grand total of 0.46. 0.64. Oof, 0.64. Okay, part C. Find the probability that a student participates in at least 2 activities. Well, what does at least 2 mean? There's 0, 1, 2, 3, 4, 2, 3, 4. Let's see. Participates at least 2 activities. Is 2 at least 2 activities? Yes, 2 is at least 2. Is 1 at least 2? No. Is 3 at least 2? Yes. Is 4 at least 2? Yes. So at least 2 activities means the probability of exactly 2 plus the probability of exactly 3 plus the probability of exactly 4. So we've got that nice probability distribution that we can go back to. And when we go back to look at that, let's see, the probability of 2 is 0.45. Probability of 3 is 0.22. And the probability of 4 is 0.14. So when we add all this up, 0.45 plus 0.22 plus 0.14, we get the grand total of 0.81. Okay, next question. Excuse me. Compute, number 3, compute the mean and standard deviation of the random variable with a given discrete probability distribution. So this probability distribution is already given to us. And whatever is happening here, they don't have a backstory, but they're saying when the event happens that you get a -6, the probability of getting that is 0.14. Right? The event of getting a -4, the probability is 0.19. The event of getting a 0, the probability is 0.24. So that's what's going on there. Let's see if we can figure out the rest of this problem here. It says part A, find the mean, round your answer to 3 decimal places. Okay, well, let's go ahead and take a look at the formula for the mean. I've got the formula sheet down at the bottom, and might as well use some color. The formula for the mean is right there. So the formula for the mean of a random variable is the same thing for expected value. You can see it is just going to be the event times the probability of getting that event, and then sum all those up. So let's go ahead and do that. So yeah, let's go ahead and do that right here. Remember the formula, let's write that up here. So the formula for the mean of a random variable is going to be, it's going to be the event times the probability of getting that event. And we need to sum all those, whoops, got way out of control there. We need to sum all those up. Lost control there again. Okay, so now let's do it. So I don't know if, let me start by using color, but I don't know if I could keep it up because there's so many that I would have to be changing pen colors like crazy. But the first one we could take a look at is this guy, right? And so the x value, and I think I've got to go over here space, -6 is the x value, right? Here's the x value. And then times the probability of getting that x value, which would be 0.14. And then we have to add that to the next situation. And I guess I'll grab another color just to kind of keep that. And so the next one is the probability. So the event is getting a -4, and the probability of getting a -4 is 0.19. Let's go another one. How about green? So the event is getting a 0, and the probability of getting a 0 is 0.24 plus. Can I keep it up? I guess so. Just have 2 more to do now. The event is 4. The probability of getting a 4 is 0.25. And then finally, black. To get a 7, the probability of getting a 7 is 0.18. And then we take each one of these pieces and multiply them. So -6 times 0.14 is 0.84 plus -4 times 0.19 gives us a -0.76. And then 0 times whatever is just going to be 0. And then I've got this 4 times 0.25. A quarter of 4 is just going to be 1. And then finally, I have 7 times 0.18, which is going to be 1.26. So I add all this up, and I get my mean of this random variable is 0.66. Now they're asking us to find the standard deviation. Standard deviation is a little bit tougher. Let me use some of those same colors. The formula for this is a little bit different also. Let's go look it up. There's 2 possible formulas that you can use, but I would recommend a certain one because we're doing it by hand. So to get standard deviation down here, you first have to get variance, okay? So when you take a look at variance, first of all, we've got this formula and this formula. They both work just fine. But the thing is, this formula right here works better if you're going to do it by hand, if you're calculating by hand. And that's what we're doing. It's just easier because you're going to square the event times the probability, and then you're going to add all those up and then subtract out the mean squared right there. Then after you get that variance, then you square root both sides, which will then give you standard deviation right here. All right, so that's the plan. Let's see, where are we at right here, I believe. I will go ahead and use some of the same colors, but remember our formula is a little bit different. Maybe I'll write the formula down just so we can see it. And that formula is for the variance. Remember, we're finding the standard deviation, but we've got to get the variance first. So this is the variance of this random variable equals, we're going to have to sum up all these little pieces. What are the pieces? Well, it's going to be the event squared times the probability of getting that event. Then we have to subtract out the mean of that random variable squared. It's very easy to forget to square that. It's a common mistake students make, so you got to be aware because you're going to have a whole bunch of little pieces and parts floating around here. And so you kind of have to really stay on top of this. Let me start with the same, I guess I'm zoomed in a little bit. Let me start with the same color that I started with before. And so remember what I'm trying to do. I'm trying to find the x in squaring that. Well, I have the x right there, so I don't know if I have to really look all the way back here. But there's my x that has to be squared, right? So that's just going to be -6. I think you're going to get seasick if I keep on going back and forth. But it's going to be -6, and that gets squared, and then you have to multiply it by the probability to get that, which we can just cheat and look right there since we already have that. And I've got it all nicely color coordinated. Okay, and that gets added to, and I got to squish it down a little bit because I've got to subtract here also. So let me try to condense a little bit at least. What was the next color? I forgot. It's red. So the next one was red. I've got the event of -4. So it's going to be -4 squared times the probability of getting that is 0.19. Then the next thing is 0 squared, right? And 0 squared is 0 times this, 0.24, which is 0. So I think what I'm going to do is just to show that, I think I'm going to put a 0 there because I know that's going to be 0. Taking a look at the next color, which is blue. And I've got 4 as the event, so square 4 squared times 0.25. Plus, and then in black, I had 7 squared, right, times the probability of getting that 0.18. And so this is what we've just done, right? We've just done, I lost, okay, there it is. Yeah, we just did this part right here of the formula. Now we have to subtract. So now we have to subtract the square of what? The mean, which is just right here. So 0.66. Okay. So then we basically take -6 squared, which is 36, multiply it by 0.14, and we get 5.04. We do the math there, and we get 3.04. That, of course, is 0, so we don't have to write it down. We do the math of that piece right there, which ends up being 4 squared times a quarter, which is 4. We do this last term, which is the black one, right? This is 7 squared, 49 times 0.18 gives us 8.82. Now we're right here with the formula minus, and then we have to take 0.66 and square it, which gives us 0.4356. So we add up all of these pieces and take away that 0.4356, and we end up getting, don't think we're done, we're not done, we end up getting the variance of x, of the random variable x, is approximately 20.4644. So how do we get the standard deviation? Well, all you have to do is square root the variance. And when you square root the variance, you now have the standard deviation of the random variable x, which it said to please round to 3 places, and we get 4.524. Last question, number 4. It says a recent survey asked 808 people how many days they would wait to seek medical treatment if they were suffering pain that interfered with their ability to work. The results are presented in the following table. Okay, there's my let x. Let x equal the number of days a person sampled at random from this population. So basically what's happening is there were days they would wait to seek medical attention. So we got 0 people that are suffering from pain right here. And start again. Okay, 0 number of days. You're suffering pain, 0 number of days, right? So I start suffering pain today, and 29 out of 808 would go to the doctor. Now, some people struggle with the pain for 1 day, and then they go. That's 429 out of 808. And then people suffer for 2 days and then go. Well, most of them were after 1 day they went, right? But after 2 days, there's still 255 out of 108. But now we're getting down to the tough people here, right? They suffer for 3 days in pain. That's 65 out of 808. Suffer for 4 days without going to the hospital. That is going to be 25 out of 808. And the people that'll suffer for a whole 5 days, like a business week, Monday through Friday, that's going to only be 5 out of 808. So they're either really tough or dumb, right? So probably tough or dumb. I don't know. I can't tell. But anyhow, that's how we're reading that. So let's see what we need to do. It says construct the probability distribution of x. Round your variable to 3 decimal places. All right. So I tried to cut and paste this stuff so we can see both at the same time, and can't quite see both at the same time. But if I zoom out to see both, everything really gets too small to be able to fill in this box, because it's 3 decimals and it didn't give me a whole lot of space to write here. So what I'd like to do is I'd like to show you the fraction also, not just go to the decimal, so you kind of get what I'm doing a little better maybe. And I guess we'll use some color as we normally do. So I'm looking at this situation right here, right? So that's going to refer to right here. And it's saying, so how does this work, right? The random variable x is the number of days they're suffering before they go to a hospital. So 0 people, people that suffer for 0 days, what's the probability? Well, all you have to do is take 29 out of 808. So if we take 29 out of 808, that's the probability that someone will suffer for 0 days before they go to the doctor. Let's go ahead and put the answer in decimal form in red. So when I divide 28 divided by 108, I get 0.036. Okay, next. People that will suffer for 1 day and then go. That's a bunch of them. And so here we are now. Whoops, I thought I was going to go with another color, huh? Jeez, I already blew it. So suffer for 1 day, that's 429. And we'll go ahead and change that to a decimal just by dividing it on the calculator. 429 divided by 808 is 0.531. Okay, and now you got the idea. Let's do a couple more with color. Suffering for 2 days, what's the probability? That's 255 out of 808. That was 255 out of 808. And what does that look like as a decimal divided on the calculator? 255 out of 808 is 0.316. Okay, I think you got the idea, so let's just do this in black pen now. Suffering for 3 days, that's 65 out of 808. Divide on the calculator, 0.08. Or also known as 8%. The number of people that suffer for 4 days, that's 25 out of 808. Divide on the calculator, and we get 0.031. And last but not least, the tough people suffering for 5 whole days before getting medical treatment. There's only 5 remaining people out of 808 that are willing to do that. And we throw that in on the calculator and we get 0.006. Okay, so now we just made a probability distribution, right? This the x values are the random variable x of the event that's taken place, and then we've got the probability of that event happening. Find the probability that a person would wait for 3 days. Okay, so waiting for 3 days, the notation means probability of exactly waiting 3 days, and I can see that. Waiting for 3 days is right there. So that's just going to be 0.08 done. 0.08 done. Okay, what's the next one? So I think what I did was I left some space so I can cut and paste this thing. I think I'm getting trickier and better, but I might actually screw this up. I don't know. Let's see. Uh-oh. Can I copy it? Yes, copy. And I want to put it over here so I can see it. I guess it just copied that. That'll work still. No, I need more detail, right? It didn't copy everything. Huh. 0 through 5, so I'll put that in. That didn't work. 0, 1, 2, 3, 4, 5. Remember, this was x, and this is p of x. That worked well enough, I think. So now find the probability that a person will wait for more than 3 days. So remember, if we're trying to represent these random variable x, right, the possibilities are 0, 1, 2, 3, 4, and 5. So 1, 2, 3, 4, and 5. And the wording here says, what's the probability that the person would wait for more than 3 days? That doesn't include 3. More than 3 is 4 and 5, right? So more than 3 is 4 days and 5 days, or more is 4 days or 5 days, I guess. But anyhow, the way we would show that is probability of 4 plus the probability of 5. And that would be showing the probability the person will wait for more than 3 days. So we've got to include all those folks. And so all we have to do is go up and look at what is the probability of 4. And no problem, it is right there. And I think I'll use my red there. It is 0.031. And then what's the probability of a person waiting 5 days? And that's 0.006. And then when we add all that up, right, 0.031 plus 0.006, we get 0.031. 0.37. What's the next question? The next question is asking for compute the mean of this random variable x. So remember the formula for the mean, right? We can always go back and take a look at it, but I think we looked at it enough. You saw it on the formula sheet. So I'll put it right here. It is the random variable, the mean of the random variable x is just going to be the summation of taking that event times the probability of getting the event, right? And then sum them up. So what does that look like? Looks like this. Use a different color, I think. How about if I use blue? What's the probability? So we've got 0. And what's the probability of getting 0? What did it say? 0.036. Now, technically, you really don't have to put that down because you know when we multiply that, it's going to be 0, right? Let's do a couple more in color and then we'll just go for it. Then the next one is the event is getting a 1. And what's the probability of getting that? 0.531. So the event is getting a 1. The probability of getting that is 0.531. Okay. Oops. Wow. Okay. The next one is the event is getting a 2 and the probability is 0.316. So the event is getting a 2 and the probability is 316. The next one is the event is getting a 3, and if you look up on the chart, the probability is 0.08. Wow, I'm running out of space here. Next one is 4, and the probability of getting a 4 is 0.031. The last one is getting a 5, and the probability of getting a 5 is 0.006. Right, and we know getting a 5 is right here. The probability is 0.006, so that's where I got everything. All I need to do is add all that up. I do that and I get approximately 1.557. They're asking us in this problem to round to 2 decimal places, so we'll go ahead and do that, 1.56. So then we go to our next problem, and that says, please compute the standard deviation for this random variable. So as you remember, we used the formula right down here, the formula for calculating it by hand. And then we square rooted both sides, and that gave us a standard deviation. So we're going to do the same thing here. And to do this, we can look back, and now remember the formula again. Start off with the variance of the random variable. That's just going to be taking the event squared times the probability of getting that event, right? Sum all those up and then subtract out the mean of the random variable x squared. Okay, let's do it. Start some of them off with color and then we'll just start to go for it. So our very first one, just like before, oh man, it's way up there. So I think what I'm going to do is I'm going to do my little trick of cutting and copying, and maybe it's still in the memory of this thing. I'd put it too far down here. No, it's gone. Okay, darn it. Thought I was going to be smart for a second with this little thing. So let's see. Let's go like this and copy that. Copy. There we go, copy. So I'm going to put it right here. And then I can move it, I believe. Okay, so remember the formula. The formula starts out. Let's get rid of these colors and start again. Okay, so the first one we're looking at is right here. So remember how the formula goes. It says take that x value and square it. So the x value is 0. Once again, this doesn't have to be because we know we're going to get a 0, but I'm just showing you. And then we take the probability of getting that as 0.036. Next particular problem, let's do this one in red, It's a 1 squared is still 1, and then the probability of getting that is 0.531, right? 0.531 right there. And then the next one we'll do is we'll do it in green. The next particular, whoops, close the parenthesis, is a 2, square it, and the probability of getting that 2 is 0.316. And the next one's going to be in pink. And the event is getting a 3, and the formula says to take that event and square it, so we square it, and the probability of getting that event is 0.08. Plus, we're getting there. I'm going to do the rest in black, so it's going to be right here. It's 4 squared times 0.031 plus 5 squared times, I'm really running out of space here, 5 squared times 0.006. And then remember the rest of the formula here. It says minus the mean of the random variable squared. If you look on the previous page, the mean of that random variable was 1.5 before we rounded it at least. And don't forget that gets squared. Okay, so now when we simplify each piece, of course this piece is just going to be 0. This piece is just going to be times 1, so 0.531. And actually, let me move this down because I don't really need that here now. Can I do it? Oh, it won't move. Still learning. Okay, but I can move it like that, so look at me go. Okay, so that goes, let me get that out of my way. There it is. Let's continue to simplify. Come on. Let's continue to simplify. So 2 squared. So we have what? 2 squared times 0.316, and that's just going to give us a 1.264. You can follow along with the calculator. 0. Now this is this guy right here. This came from this one. This is 0.72 plus, and then this is this guy. 4 squared, and then multiply, we get 0.496. And then this guy is really getting kind of tight here. I had to zoom in to make this happen. 0.15. And then finally this last little bit right here. I'll do that in a different color. We take 1.557 squared, and we get minus a 2.4242. Let's see, 424249. Okay, we do the math. We add all those pieces, then subtract out that red. When I add all these pieces together, if my math is correct, it's 3.161. We subtract out the red, which is still 2.4242. I get lost. 424249. We subtract that out, and we now have, now remember this was the variance, so the variance as the square of the random variable x, which we end up getting 0.736751. So 0.736751. Now remember, we want the standard deviation, and to do the standard deviation, use square root both sides. And now we have the standard deviation of our random variable x equals, and we get 0.85834. Of course, they're asking us to round this to 3 decimal places, which is 0.858. 858. There we go. And that's it for our probability of these discrete random variable x's using these probabilities distributions, and basically going through the chapter 6, which is discrete probability, looking at finding variances, the mean of the discrete random variable, and ultimately finding the standard deviation of the discrete random variable. I hope that helped out, and I hope you have a great day. Take care. Bye.